Hi guys, we are going to review now the practical case corresponding to lesson 5.2 Outliers and Influential Observations. First, you need to download the file from the virtual campus and then execute it. You load it in Gretl, and then you will see that you have 5 different cases for the y variable and a single regressor. If you choose base data, Control-click X, and then right button XY scatter plot, click OK, you will see that you are estimating a perfect regression. The data has been simulated. The true value for the constant term is 2.0. As you can see, the estimate is very close. The true value for the slope is 1.5, and as you see, the estimate is also pretty good. There's nothing remarkable in the shape of this scatter plot. Now, if you do the same, choosing influence 1, control click, X, right button, XY scatter plot, you will see that the previous sample that I am pointing at has been contaminated by 3 outlying observations. This point, which is called A in the presentation, this point, which is called B, and this point, which is called C. If you estimate this model by least squares, choosing influence 1 and choosing X as regressor, you will see that the estimates are pretty good because these 3 outliers are not influential observations. They contain each other, so the regression line stays more or less in the same place. The R squared, however, will be deflated. And if you run a test for normality of residuals, you will see that the histogram is very weird due to the outlying values over and under the regression line. And you will also see that the p-value for the test is very small, meaning that the null hypothesis, the error is normally distributed, should be rejected. Now we will delete some of these points and we will see what happens. If you run the scatter plot for influence against X, you will see that we deleted point C and nothing remarkable happens. The estimates continue being pretty good, and we have here the layers A and B. As you can see, the regression line stays more or less in place. However, in influence 3 against X, the scatter plot shows the effect of deleting point A while keeping B and C. As you can see, the estimates worsen a bit, but not so much because this point here, this guy here, is keeping the regression line more or less in place. If you run influence 4 against X, you will see in the XY plot, you will see that we deleted A and C, and we kept B in the regression line, and the regression line is completely misplaced. So the solution when you have outliers and influential observations is deleting the points, but you should be very careful in deleting all of them, all the points that could be outlying and influential. Okay, how can we detect these outlier and influential observations? I will run again the regression model of influence 1, that is, with the 3 outlier observations against X. As you can see in the option Analysis, you have a test for influential observations. I will increase the size of this window. What you have here is for the 25 observations in this sample, you have the residuals. The residuals for the last 3 observations are pretty large. These correspond to the outliers. You have here the leverage coefficient. The leverage coefficient points to observation 23. This is point C, and it tells us that this point is outlying with respect to the x-axis. Here you have the influence coefficient, which is also pretty large, and you have here the DF fits statistics. 24 and 25 are the points A and B. As you can see, they are very influential. And you have here the leverage and influential coefficients. The right way to proceed to solve this issue would be therefore to delete observations 23, 24, and 25. All of them, not one or two, but all of them. And that's all, guys. Good night and good luck.